We're going to begin our subtraction, second grade, double-digit subtraction talk by discussing and showing you the same way we started addition, place value blocks, number lines, part whole models. We'll just talk about place value blocks again with the tens and ones mats, show them regrouping, show them you have to take 110 and change to 10 ones and so on and so forth and move things around so they get to move things around and feel it before they get to some of these visual models that are kind of the next stage in their math development. This should go fairly quickly for second grade. They've done this a bunch in first grade with smaller numbers. And so number lines is the major one we're going to focus on with a link to the part whole model. First type of problem is a subtraction problem with no regrouping. And you see that right away. The students may see that as well. It just depends. The nice part about subtraction is on a number line is that it has two definite endpoints, and so it's easier than the addition for most students because you know where you have to stop. Sometimes with addition you don't know where you have to stop. Also, subtraction is seen by most students as taking something away, and it's really two things. It's taking something away, and it's the distance between two numbers. So the distance between 78 and 32 is this answer, and it's also 78 take away 32. Okay, so students can visually see the difference between two numbers on a number line, which will help them in their later on development with some different number line concepts. Okay, so since we know the two endpoints, it's nice to maybe start with, okay, I know that's where I'm starting at 32, and I know I'm ending at 78. So the students know where to start and stop, and the answer is going to be this space in between. So if you taught the addition with the number line, students know steps and jumps, and students should be fairly good at finding their landmark numbers, jumping by tens, jumping by fives. Okay, so to start off with, we'll go to our landmark number. So we added 3 to get from 32 to 35. Most students at this point, since they've had that experience, can go from 35 to 45, from 45 to 55, from 55 to 65, and from 65 to 75, and make sure they put their tens above it without a problem. If you went too quickly through it, maybe this is a while after you do the number line in addition, you're able to revisit this and practice this a little more, and that's okay. But most students, if they've had enough practice with it, should be able to go 35 to 45 and know that that's 10 apart. And then they have to finish up by getting to their end point by adding 3 more. All you have to do to get your answer is add up all of your steps and jumps. 10, 20, 30, 40, 46 is our answer for the distance between 78 and 32. Some students may need to take this extra step, extra jump. So if they had 78, 32 marked, they would start off the same way most students would. They'd get here. Some students may need to make that smaller jump first, that 5 jump instead of the 10, because maybe they can't go from 45 to 30, from 35 to 45 and know that that's 10 away, even though they can see it visually. But 40 to 50 is certainly simpler, 50 to 60, 60 to 70, and they can't go 70 to 80 or they've gone too far. They could certainly and then take 2 away, but that's another concept that may be tougher for students. Okay, and again, making sure you keep track on top of what you're jumping or what you're stepping. They should be able to make this shorter jump and then step all the way to the final destination. So again, adding up the tops, 10, 20, 30, 5 and 5 is 40, and 3 and 3 ends up making 46 for your answer here. If we're connecting that to the part whole model, we are putting 78 here. We'll make this our question mark, and we'll put 32 here. Now again, it doesn't matter where the part goes, your 78 is your whole number, 32 is your part. Now, a lot of times teachers will tell students 78, or to put the whole is always your bigger number. That's a misconception. We don't want to use that language with students. We want to say the first number in subtraction is the whole number, because when you get to fifth and sixth grade, you end up having, the first number might be a negative number, and then you're subtracting a negative or positive from that negative number. This number in a subtraction sentence, as they get older and more complicated math, isn't always the bigger number, because they can get negative answers. So be careful to plant that seed that is wrong, because they will then flip things around on us, and that ends up changing the whole problem when they get older. So the first number is the whole number, and we know our answer is 46. And if you're doing it this way, the whole goes on top just like before. 46 and 32 are the parts that make up that 78. Let's try this with a problem we know, if we did it the standard way, would be regrouping. Is that going to change the way we do it on a number line? 49, so I'll again mark my endpoints, 49 and 81. I mark those just so I know that my answer's here. I just have to figure out the distance between those two. Okay, so I'm going to take one step to get to a nice landmark number. Then I can count by tens. So I did my big jumps, 10 for each one. And I'm at 80. How many more do I need to go? I need to go one more to get to my final destination. So 10, 20, 30, and two more is 32. Did I end up talking about regrouping, worrying about regrouping, freaking out because the second, if I had, no, I didn't do that at all. The number line, nice visual, steps and jumps, that's all it is. Very simple way to do this, might take you more time, but a lot easier than a procedural steps that we were telling the kids to do, okay? This is probably one of the only ways they're going to do this, unless they're counting by fives or counting by tens. And so again, if we put this on the part-whole model, 81 and 49, we would say 81 is here, that's the first number. We can put 49 wherever we want, doesn't really matter. I know that I'm taking away one of the parts, and I have the whole thing. And then my answer, again, was 32. So, putting it down here, 81 is the whole thing. 49 is one of the parts. 32 is the other part. And so, getting students to use these different models and different representations will help you with word problems, will help you with your algebra problems, missing number problems. And so using these visuals is a powerful tool for students, especially this number line piece that will help students in their math knowledge. So that's the first way we're going to show you subtraction, number line, part-whole model.